here, and 4 pi is also here, I guess.
Yeah. Yeah. 2 pi plus pi over 6. Is this one B?
No,
Then you're
I'm
talking about
finding,
the other possibility?
yeah.
Oh, let me think. Right. I think this one is the only one that we can find between 2 pi and 4 pi. The 2 pi, and then you go on, you go like 13, and this is a 13 over 6 pi. Is it? If you move a 2 pi in here, then this is not that angle anymore. It's not that point anymore. It's not that angle. This is the angle. You know what I mean? It's not
Yeah,
the.
the angle. Yeah, I know. It's like 13 pi over 6, and then plus pi over 2 is like from here to here.
Yeah, that one. If you change that one, that angle is different. So it's not this point anymore, right? It'll be this
Oh,
point.
right.
It'll be
Yeah,
this
that's it.
point. Yeah.
Okay, well then plus 3 pi equals.
Plus 3 pi. Plus 3 pi also probably not working. Plus 3 pi would be this point, right?
Oh, wait, it doesn't. It's still. Oh, right. Yeah. Sorry. I was just thinking about like I was just trying to take into account like all everything on the. Oh, oops. Let
Yeah.
me go back.
That's what we do with trigonometry. This one is a.
So I was just trying to account for everything on there, and I kind of forgot that it's. Oh my god. I'm doing all of this as a pain.
They don't have to rewrite that because we don't really we.
Oh,
This is
okay.
one. This is one. That we-
It's okay. It's
So this is
that was 13 pi over 6.
yeah. So which means 13 pi over 6, which is also this point, right?
Yeah.
Still this point, yeah. So that's the one. So this answers A. And
Then
how
we
about
find other polar coordinates. So it's
how
like
about B? Yeah,
minus
negative
3
3.
plus.
Yes. It's a little tricky.
That still counts, right?
Yes, that's the one. Yes. Basically here
This
and
one.
expand it. It's good.
Is it this one here or not? I don't think it is.
No.
Yeah,
So
it's just
negative and positive only, they rely on the same, you have to be on the same line, right? So then you expand, right? If it's not the same line, not okay. But if it's the same line, it would be plus a pi.
I think this is about.
Yeah, minus 2 pi, yeah, right.
Yep.
So the polar coordinates, they do have a, other possibility of the polar coordinates, which is a little different with XY system. XY system is certain, right? You can't really have a second option. Oh, they summarize, wait, they summarize this in here in saying either you are, this is basically, I think this is basically A and C, right? Same R, And but you have a negative r, you have a plus a pi, right? Which is your plus a pi. Plus a pi. Of course, if plus a pi, you can also make it 2k pi, right? That's the
Yeah.
so here is integer pi. Let's go on a little more. Oh, since we talk about, I just talk about there's like XY system, which we used a lot before. They also can be both. Sometimes that needed both. You have an XY system, at the same time you have coordinate system. And their relationship is this. If I draw this and then this polar system, so any point, this is the X value, this is the Y value, and this is R, this is theta, right? So the relationship is this. It's kind of like the unit circle trigonometry thing, right?
Yeah, okay.
That's their relationship between
So it equals,
polar.
what does the R mean here? Is it just like a variable?
Oh,
Oh
R
wait, it's the point.
is
Yeah, yeah.
is the
Okay, sorry. Okay, so it's the point. So then the rest. Oh,
this
okay,
is
yeah, that makes sense. Their normal coordinates are given by that.
yeah. This is talk about a relationship, and then by definition we can convert from one coordinate to the other coordinates. Let's do example 4. Right. Example 4. Find regular coordinates. I mean, according to this relationship.
Okay. So wait, hang on, let me put this in my calculator. How do I switch my calculator from degrees to radians again?
Degree to radian. There is a button called RAD, and they switched into radian.
I don't see it. Okay, whatever. I can remember. Okay, so
Oh, or sometimes they have a button with degree. You press it again, then you become radian. 3 square root 3. Yeah.
oh yeah, yeah, I found it. 3 square root 3. Yeah, it's fine. I can. Okay, so
Yeah. Right. The other one is negative.
oh wait, no, it's plus. Okay.
Yeah, negative 2 square root 2. Close negative 5/4.
Yeah. Okay.
Okay, this is a which means this is a coordinate number 2. Negative positive. Yeah. Negative Yeah. Okay. So this is from polar to xy coordinate. Let's see. And again, how about changing to polar? Well, from your rectangular coordinate. Find example 5.
Okay, 0, 3. So
Yeah.
oh, it has to be pi over 2 because
Yeah. Yeah. Good. Or you can this is the algebra way, or you can draw it. This is a 3, 0, 3. And I can see the r is 3 and the angle is pi over 2. By watching the graph is also another way, right? Drawing the graph can also help us to find polar coordinates. We can algebra way, but we can also use geometry to check it or to solve it. And example 6. Of course, there is other possibility that coordinates. Let's do 6,
okay.
which is a little bit more complicated. Ah, x squared, y squared. Good choice. From algebra, that's
Would it be r to the power of 2?
Yeah, r squared. It's because r squared, sine squared, and cos squared. And that one is 1, so it's r squared, right? This one is 1. Yeah. 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 Wait, wait. This is r squared, right?
Yeah.
So this would be r squared times that.
It's r squared 2. It's just that I crossed it out. That looks weird.
Wait, wait. R sine cos square plus sine square is 1.
Oh, right.
Okay,
Yeah,
that's
okay.
the
It's
identity
just
thing.
1. Okay.
Yeah.
Okay, sorry. I didn't remember that I just squared the r's too.
Yeah.
Okay, so equals 1.
So you can use this, or you can just draw it. 2, x2, positive, negative 2. Because this is r, right? This is 2. This is 2.
Oh, yeah.
Pythagoras can also help.
Beautiful.
Yeah. 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 Yes. So that'll be 2 square root 2. Good.
So then
So you have R. Because you need theta, right? Oh, okay.
I think I might need some help from here.
Oh, yes. So if you use this one, you can use cosine theta equals to x over 2 square root 2. And then since x is 2, so it's 2 over 2 square root 2, which is 1 over square root 2. And seeing this graphing, so that'll be just, well, using cosine -1, 1 square root 2, which is pi over 4, right? This is pi, if this acute angle is pi over 4, right? But if I'm describing this one in here, this is negative pi over 4, right? I'm getting here, right? Does it make sense? So the
Yeah,
acute
okay,
angle is pi.
so it's negative pi over 4 because it's an acute angle. So so cos theta equals x over 2. Oh, okay. Yeah, that
Uh-huh.
makes sense.
Yeah.
1 over square root of 2, which is square root of 2 over 2, which is, yeah, I thought it was connected in some way to pi over 4. That makes sense.
Yeah. So in the end, that'll be 2 square root 2 negative pi over 4, right? That's the polar coordinates, right? This is the r,
Yeah.
and this is the theta. And there is another way, not using cos, is because basically any point in here we always have a 10 because they normally always tell us x and y, right? Wait, this is y, this is x. So we have 10 theta, the acute angle 10 theta, not exactly the final theta. Well, is for this one y over x because we can use trigonometry, right? It's also trigonometry also looks like that. It's a negative 2 over 2, which is negative 1. That makes sense? Which I can also find is pi over 4, right?
Yeah.
Yeah, so I can use 10, so I use theta 10 negative 1, negative 1. So it's,
Oh
yeah.
wait, why are we finding tan? We just need to find like the polar coordinates, so it's not that big.
10 is used more often because we don't have to. It's kind of like because they give us y and x normally, right? Because y and x always equals to 10, right? This
Yeah.
is we use in trigonometry. It's more direct data, I guess. You can totally use cos, same result anyway. Just check with the graph, and you'll be okay. Is that okay for this one? And drawing it
Yeah.
also helps a little. So,
Could you repeat why we need tan? Is it just for?
oh, 10 is just if you want to do it kind of, if you use 10, it'll be kind of more accurate. For example, this one is using
What?
special. 10 is more accurate. Why?
Tan,
For
why
yeah,
would it more accurate?
in this question, it's okay, right? But think about this is special angle, right? For example, if I did give you saying 3 and negative 4, if this is your coordinates, let me use a different one, like this 5, negative 5. If I use this one, and you're finding r squared is equal to 3 squared plus negative 5 squared, right? So that's a
Yeah.
square root number, right? So if you
9
find,
plus 25.
yes, 9.25 is 9.25, 34, right? So if you use this, and if you find cosine, which is negative 5, wait, negative 3, actually positive 3 over square root 34, right? See, when
Yeah.
you use this one is not that accurate anymore. But if I use 10, is the original data, is negative 5 over 3. So this one is more accurate, kind of. that make sense? You have finding r, which is totally could be a square root number, but this one is still integer. Does that make sense? So 10
Yeah.
is somehow a little bit more accurate because it's more the direct data x, direct data y. I'm not using like a square root of it. I'm not using r equals to square root like a x squared and y squared. And this is in progress, so but it's a little bit not that accurate. But if it's a special angle, then okay. Is it making sense? So that's why we use 10 more often. But they're both okay. Does it make
Yeah.
sense? 6. So we kind of can summarize. Oh, they're not summarizing. Then we don't have to summarize. In example 6, 7, this one. Find polar coordinates. Point whose rectangular coordinates this.
Okay.
Yeah. Good.
How do I tell if it's positive or negative?
Um. Well, I normally choose positive. It's easier. Of course, you can be negative, right?
Do you want to choose positive?
Yeah, we normally choose positive because it's the first thing that we learn polar, right?
Okay.
And you
Wait.
also know that I can change that into negative value, like a value, right? But I have to adjust the theta. I have to think a little bit, one more or two more steps.
I think it's negative, like if it goes down like this.
Oh, I guess you use positive because it's a distance. Of course, you can use negative.
Okay. So do you want me to use positive?
Yeah, positive is easier.
Sure.
Negative is only because they ask.
Okay, so it's 1/2.
Mm.
Oh. Oh, okay, this is like this is like pi over 3
Yeah.
plus pi, I think.
Yes. Oh,
4
yeah.
pi
4
over
pi over,
3.
yes, 4 pi over 3. Yeah.
I think it's negative too. Are you wait, or maybe it's not. Oh.
Yeah, if you use -2, it can be also okay. If you use -2, then you have to say this is the one, right?
Oh
Here.
wait, never mind. It can't be -2 because like okay, I got it.
You have to use this angle if you use -2, which is, one more step by expanding that, right?
Yeah.
Oh, here is what they summarize. Say based on all this, you're using cosine, he's using 10. Of course, we're checking with the graphing. So both okay. Y over x is more direct data, probably more accurate on some occasions. But you can use cos. You can use cos theta equals to cos theta is what? Is x over r, right?
Okay, so okay, scroll up.
Yeah.
Okay, tan theta equals y r. Oh, okay. Yeah, that makes sense.
Yeah, you usually
I get
consider
it.
it's x or y. And then, oh, this is what they summarize for all this. Oh, if they use 10 in here, they can use the 10 in here, right? I mean, the inverse 10 for 1 and 4th coordinates. It's 2 and 3 coordinate they use, well, they plus a pi, basically. Either you are in here, or, which is the calculator thing, right? Because the calculator's domain. If you're in here, you have to use pi to plus that, right? Does that make
Yeah.
sense? So this is the summary. Go on a little. Oh, he's using more. Let's do. He's using the formulas. I mean, trigonometry definition formulas, and on this. Say example 8. He's telling you a relationship about this.
Okay, so the polar coordinates would be 6 theta,
Yeah.
right? And theta equals, oh, we could just equal anything.
So in the end, they want x, y, right?
Yeah, xy. Okay,
And
so
this is a little tricky. This is the first time I did this. I have no clue what they talk about. Because remember, we have a formula relationship. It's this.
oh yeah. Okay.
It's a little different than the, because they didn't really say R is 6. Oh, then this one too. Let me mark this.
Oh wait, yeah. R.
They didn't say
Okay.
R is 6. They say
Sorry,
it's 6.
sorry, sorry, sorry. I'm used to like, x equals. Okay,
Yeah,
okay.
yeah. This is difficult for the first time. Um, I'm drawing here because I want X, Y.
Okay, so first it's
Hmm. Oh, you square it? Hmm. Okay. That's also one popular way. Let me see what we can get this somewhere. Hmm. It's a little difficult to transform now.
could you help with this? I don't really get
Yeah,
it.
so this is gonna be one way to do it, like square it, which is very good because you square you have r squared. But you're also gonna feel that you get stuck in here, so maybe not this method. But well, later we have a question like this using your method. What we do want here is more r square can be also happening with this. I can time a r, right? because they have an r already. So I time on r, which can have r squared. And you time on r on the left side, you also time on r on the right side. This is for the purpose of more xy happening. So this way, more xy happening, because r squared is x squared times y squared, right? Does that make sense? This r squared is x squared plus y squared.
Yeah.
And on this way, it has something very nice too, because it's
so
x.
then x.
That's r. Wait, actually r times cos theta. Oh, this is, I mean, this part is x. See, 6r times cos theta. R times cos theta is x, right? R times cos theta is.
Okay. Yeah, that makes sense. So equals 6x.
Yeah, so now we have an equation about the rectangular form, right?
Okay,
That's totally just the xy system. I mean,
okay, so then how do we find out? How do we find x and y?
oh, this is already x and y, but the problem is let's see, they say transform this equation, and I think we already transformed the equation into a rectangular coordinates, because this is a x coordinate, y coordinate, x coordinate. This is a xy system equation already, right? Does that make sense? We finished the first question. And the second question is, on the other hand, we haven't finished. Identify the graph, which means you have to also graph this equation in xy system. Does that make sense? I finished transforming, but I have to make sure how to, like, I know how to draw it. Right now, it's x squared plus y squared equals to 6x. But how do I graph it? What does this look like? Do you remember circular equation in xy system? X minus a squared plus y minus b squared equals to r squared. Do you remember this?
Oh, yeah.
This one look a little bit like that one, right?
Yeah, I guess.
So I can try to, let's see, try to change it in that form if it is possible. Of course, I can put it in the decimals. They can also show me x minus 3, right? Because x squared minus 6x plus y squared is 0. And then plus a y squared. For this part, I already need, I need a 9, right? I need a plus a 9 so that I make this 3 term as x minus 3 squared. Is that making sense?
Oh, okay. So we just, what's u? What's this thing?
Which one?
U?
Oh, that's 0, 0. I'm moving it to the
0. Oh, okay.
right.
Yeah, thank you.
So 0. So I'm changing it into a circular form.
Yeah, it's like completing a square, right?
Yeah, completing the square. Because I want to
And
see
then
whether it's
after?
this. And then I can draw it because it's identifying the graph. If I draw it, that'll be a 3, 0, right? 3, 0 as my center. And my readers, this size of my readers is also 3. So I guess it would be something like this. Did it make sense? The circle.
Yeah.
Did it make sense?
Oh, okay. So it's a circle, and then we find the radius.
Yeah. We find a center, we find a radius, we can draw the circle, right?
Yeah, I guess. How are we finding the rectangular coordinates now?
Well, rectangular coordinates is just wait, transform the equation from polar coordinates to rectangular. Oh, this one is already is the rectangular coordinates. This one is already that. It's not talking about one point. It's a lot of points basically. Before it's all this, which means all the points in here. As long as you satisfy this equation, that's the point. That's the coordinates. that make sense? It's not just one point. It's the equation. We transform from this equation into rectangular coordinates equation, which is this.
Oh, okay, so that's the rectangular coordinates equation. So that's how we
Yeah,
find it,
yeah,
right?
yeah,
So then that is a circle. Okay,
yeah. Does that make sense?
I guess.
Yeah. And also, which means in this circle, now we say this is a circle and this is the equation. I can also say it's a r, wait, let me think. It's a 6 cosine theta, and theta is also all in here. Is that again? They're all in here. Is that again? This is another way, which means we have two ways to express this circle. One is in xy system, and the other way is in polar system, which is this one. Is that again?
Yeah.
Yeah. So on the other hand, which means I can basically summary saying I can draw a circle. This is a polar system, and I can say this is r equals to 6 cosine theta. That's also an equation for this one. On the other hand, I can this one and x squared plus y squared equals 6x. Both of them are working in two different systems. So the key for this one is time r. This is basically what they said. Multiply both sides by the equation by r. So more, x squared plus y squared happens. How about 9?
Okay. Oh my God, this is okay. 4 cosine.
You have 3 equations there.
I guess, and then the oh, oops. Okay,
Yeah.
so 9 over y equals oh, I think I kind of get it. Y equals cos. It kind of sounds silly, but like
Now this part I get it. This is nice. You substitute r cosine theta instead of x. Very nice. And then you substitute y, right?
yeah.
Or you can substitute x, y both at the same time. Just substitute this, and then there's all our, theta thing, which is polar coordinate. You just substitute in here and substitute in here. That make sense?
Okay, let me look at that. Okay, so we substitute. Oh, x equals r. Oh, okay. So equals 9 over 4. Is that right?
Yeah.
I
And
still don't really get how we can find it now.
oh, this is already changing into r, like r theta, which is already polar coordinates. But we can simplify this a little bit because we know sine theta times cosine theta is sine 2 theta almost, right? Is it sine 2 theta?
Yeah.
Yeah, so which means if I get a r squared times 2 sine theta cos theta, which is 9/2, right? I times 2 on both sides. So I'm having r squared sine 2 theta equals to 9/3, which, well, could be the final result for this. This is also pretty much the same. This one is just a little bit more simplified also. Does it make sense?
Okay, so r, so that equals 9/4, and then oh, 2. Oh, okay, I get it.
Mm.
So then so then sine 2 theta equals.
You don't have to go all the way. You can just leave it there. This is just
Oh, that's it. We can just figure
yeah.
out from there.
When they say polar coordinates from another equation, it just means an equation of r and theta. So this is already an equation of r and theta. We can just leave it
Yeah.
there. You don't have to change it. If you want to find sine theta or like theta, it's also okay. But you can just leave it there. It's already enough information, enough. They use this same thing. This is times 2, making the fraction goes away. So whenever they say about the rectangular coordinates in this kind of situation, when they give you an equation, it just means another equation only. We did 9 already, so we can leave a little homework on this. Homework is page 565. This is the homework, little part of homework. How long do you have time for homework?
Okay,
An hour?
like an hour maybe. My sister's birthday is tomorrow,
Okay.
I have a debate, and I have like a debate and debate camp from Tuesday to Wednesday.
Okay. So let's say then one choice for each column.
Okay, so what
Page
page
565. 565.
565,
And then 38.
38,
Yeah. 54.
through 54.
Yeah, no, just 38,
Oh, okay.
54, and 66, and then 75 to 82. 75 to 82. Yeah, this is a little more difficult. This is the last
Okay,
two
yeah.
question style. We go on a little polar equation and
So
graph it.
it's the 38, 54, 66, and 75 through 82.
Yeah. It's the equation and the graphing. For the first one, identify and graph the equation. R equals to 3.
Yeah.
How do you find the graph of this?
Okay, polar equation circle. Oh, r equals 3, where x equals r. Oh, okay. Okay, so r equals 3. So 3, I think.
Yeah, this is
3 cos.
but basically they have theta has no requirement, right? I mean, theta could be anything.
Yeah,
You know,
and 3 is the radius, right?
Yeah, kind of. It's all satisfying, right? Is the entire, oh, this is rated here, circle, right?
Yeah.
So R equals to 3 is a circle like this, right? I can prove it by another way, is by rectangular coordinates. which means, remember they said that so for this kind of equation, we can either, time r on both sides and or like making r squared happening. So I can make r squared happening here. So r squared, I square it on both sides. R squared equals to 9, which is still the 1, right?
Yeah, okay.
And then r squared turns into x squared plus y squared equals to 9, which is the circle in the xy coordinates, right? Is this
Yeah,
a circle?
so R to the, oh yeah, that's how it works. P is that it? So and like the, oh my God, I got a bug bite. So okay, so the circle formula is x
Yeah, x squared plus y squared.
equals just like c, and c is the radius, right?
Yeah.
Ah, okay. So R to the power, so that's R to the power 2. So the radius is 9.
Yeah.
Okay.
Radius is 3.
Wait, what?
Well, because 9 is r squared, so radius is 3. Right?
Oh, okay.
Yeah, the
So
form.
c squared or R squared, I
R
guess.
squared. R squared. Is the
Yeah, okay.
original one that we use in like a circle is this, right? R squared. Okay.
Yeah, it's like x.
But even the square for those. And then now we can just also say r equals to 3 is the circle. As long r is a constant number, it's basically a circle, right? This is r equals to 3. This is r equals to 4, right? There's r equals to 5, right? It's kind of like a global. Example 2.
Oh, okay. So theta equals pi over 4. Oh, wait, never mind. Maybe this isn't that hard. I was like, theta equals, or well, R times.
We don't, we have r. We don't have r, right?
Oh, we don't have R?
We don't have r. Which
Right, okay. So we're
there
just gonna
is,
have this one. I think this is easy. Is that
yeah,
about
yeah,
right?
yeah, yeah. And which means they don't have r, which means r is, there's no requirement for r. R could be any value.
Yeah.
So which means any point on this is okay, right?
Yeah,
Any point
okay.
on this is okay. On the other hand, if you expand that, it's also okay because you can also be negative, right? So the entire, this line is also, oh, okay.
Okay, yeah.
And I can also check this for like a, algebra point of view. So I can tan it because I know tan theta is y over x. If I tan it on both sides, so tan theta is 10 pi over 4, which is 1, right? And tan theta is y over x. I also have y x, which is also that line, right? So I'm using another way to, I'm using graphing to do it, and I can also use, xy coordinate to prove it too. So which means if theta equals to pi over 6, like this, that's another line, right? If theta equals to saying 3 pi over 4 is this, right? Any time if theta equals a constant number, you can say it's a straight line, right? Does that make sense? This is a circle, and this is a line, as long as theta is a constant. How about this one? Example 3. Identify and graph the equation. Yeah. R equals to
Oh,
Y
this
equals.
is kind of easy.
Yeah. Just the line, right?
Yeah, sorry for the wobbly line, but you know,
Yeah.
you get the
Yeah.
point.
Yeah. Y equals to 2 is that is this. So it's a here's a horizontal line is the graph of this one. And also in the same spirit, you can see example 4 or cos theta.
Okay, oh, this is also pretty good.
Yeah. That's x, right? X equals to negative. Yes.
That's easy.
Yeah. And then, oh, they want to summarize this theorem. As long r sine theta is a constant number, it's a horizontal line. As long r cos theta is a constant number, it's a vertical line, right?
Yeah.
Here again, a little similar as the previous one. Example 5. Example 5.
Oh, okay, yeah. This one's kind of hard.
Yeah.
So 4 to negative 1, I think.
R times theta. Oh, you
Would that
want to,
be?
yeah.
I don't know. I was trying to transfer to the power of negative 1 over to there, but, you know.
Oh, so it's not r sine theta because r is in here. Yeah, looks like that way, but it's not exactly the
Huh?
same. So you want
Yeah.
r
No,
sine.
no, I wrote it here and then.
Let me see. Then if that's the case, then you have your sine theta equals to r over 4, right?
Oh, right, right. I can just write that normally. Okay, yeah. So y equals r over 4, wherever r is. How do I graph that?
It's a little difficult to graph because we.
Okay, r equals 4 sine theta, so that's like 4y. No.
Not
I don't know.
exactly.
Actually don't know. I can't think about how to graph.
Mm. This is kind of like a previous question. Let me show you. The one that I time r on both sides. Do you remember that question? I have a question that I time looks like this,
Oh,
right? I
r to
time
the
r
power
on
of
both sides, right?
r to
Same
the
thing.
power of 2 equals
Yes.
4r sine theta,
Yeah.
which I don't know how that affects anything, though. I'm not sure how to.
Because you want r sine theta happening to be the this is one. This one is
Oh,
y,
right.
right?
So
That's
r to the
y.
power of 2 equals 4y.
Yeah. And r squared is also x squared plus y squared.
Oh, r squared equals x squared plus y squared. Okay,
Yeah.
yeah.
Yeah. Oh, this one I can draw it because I know this one enough
Y
in y system.
x plus x to the power of 2, and then minus 4 times 2, 2, 4. Oh,
Yeah, good.
minus. Okay, so minus 4 minus square x power of 2 minus 4
Yeah.
times x minus 2 minus.
Wait. Uh. Well, don't I want like because this is a this looks like what? This is like look like a circle equation.
Yeah, kind of does.
The circle equation is one of the typical y circle equation x minus a squared plus y minus b squared goes to the r squared, right? I mean equals to the radius squared. So we might use this form to draw. It's easier, I guess. Yep.
Yeah.
So this one is becoming so x squared is already finished the complete square thing, right? Because I don't really have other x. But this
Yeah.
one is becoming here. This one is becoming x squared plus y minus 2 squared equals to 4, which is 2 squared, right? Which is almost like this one. See me?
Okay, so x minus, oh, right, yeah. X minus a, okay. So x, okay, so the y minus 2 thing makes sense, but how does the x to the power of 2 thing work? Oh, wait, let me think. Minus 4, 2, minus 2, 0. Oh, wait, never mind. Okay, it needs to be minus 4, but it has
Minus
equal,
0.
oh, x minus.
X minus 0.
But oh wait, you can just move it over to there. Right, right. I
Yeah.
see your point now. So then so then R equals 2,
Yeah.
and
The center
the
is
point is the center
yeah.
is 0 minus 2,
I think 0, 2.
0, 2. Oh yeah,
No,
0, 2. Sorry,
very
my
sure.
mistake. And yeah, that's about it. I don't really want a graph.
So if we find that 0, 2 is in here, and reader is also 2, so this is a graph like this, right? Coming in?
Yeah,
Make it
yeah, okay.
clear this thing here. 2. Yep. Yeah, so that's yeah, that's the graphing for this. It's also another circle, right? Now we have in our mind in the circle and line.
Wait, can I go to the bathroom really
Sure.
quickly?
Sure.
I'm back.
Hello.
Hello? Yeah.
There. Example. Oh, this one was finished. This is another form of the circle, which basically when r is any constant number, time cosine theta is a circle, and this time sine theta is also a circle. Well, let's see 6 then. When it's 5, let's put 6. Six. Five.
Okay, so I do.
Yeah. Yes.
Minus 2x.
Yeah. Yeah.
Okay,
Yep. Oh, the origin is here, eh? Or the polar.
yeah.
0, 0. Okay, cool. Which in a way is this is the polar since you are in here, right? And that's a negative 0. Does that make sense? Either is this or this.
Yeah.
They're both. Okay, good. And then we can summarize it by this. We don't have to memorize it. And also, you learn pre-calculus to learn for the future to learn AP calculus, right? Is that the purpose? Is that the plan, Isabella?
I don't know. I just had to take pre-calc and then after
Oh,
that, like I don't really know.
okay. If your plan is to get the AP calculus, then you don't have to learn so much because, well, pre-calculus contains a lot of stuff like AP calculus doesn't really learn.
Yeah.
Okay, this is the one. You can also use decimals, so you can put in. They can give you the graph. This is as long as this size is a constant, 2a or negative 2a, time like sine theta cos theta is always a circle. How to get it? You can use decimals to get it. And now we say it's a test. polar equations of symmetry here. Yeah, this is a theta. If this is r theta, then this is r negative theta, right? Is that it? Does that make sense?
Yeah, okay, so that's polar equation. So r theta, r negative theta, okay.
Yeah. And then I can somehow, say, if I replace it, original is r theta. If I replace the theta with negative theta, if it is still the same equation, then I say it's gonna be, well,
Negative
look,
r?
yeah,
Negative
no,
r.
not negative r. It's just negative, well, it's still r, negative theta. And so it's gonna be have symmetry with the polar,
Oh,
with
okay,
the
yeah,
polar
symmetry.
axis.
I thought you were saying it was on the same line.
Oh. It's because in XY system we talk about symmetry, right? In this time for polar system we also talk about the symmetry. So which means if you replace theta by negative theta, if the equation, for example, before it was r like a 6 cos theta, if you replace theta by negative theta, if that's the same equivalent eventually, then I can say they probably have they definitely gonna have a symmetry to the polar axis. Does that make sense?
Yeah, okay.
And for this one, this is a symmetry for pi over 2, right? Symmetry for theta equals to pi over 2. Then I can say I replace my original theta with pi minus theta, right? If I replace it theta by pi minus theta and r is the same, if that's still the same equation, equivalent equation, and I can say they have symmetry respect to lines theta over theta equals pi over 2. Does that make sense?
Yeah.
Yeah, for example, before, if I draw the one is like this is the symmetry through like a polar axis. And if it's more like this, if it is more like this circle, then it's a symmetry about line pi over 2, right? Theta equals line pi over 2. And here's the last symmetry. Symmetry is about the pole. That's origin. We call it origin before, now we call it the pole. And I will replace my theta with theta plus pi, which is r theta plus pi. If still equivalent result, then I can say it's symmetry respect to the pole, right? That make sense?
Okay, r theta minus. So it's symmetry in respect to the pole. You mean like the x-axis, the
Yeah,
line theta equals, oh wait, this one. Right. So it's respected to the pole which is x, x, the x-axis.
yeah. Theta plus pi. This is theta. No, this is theta plus pi, right? This is theta. This is theta plus pi. Did that make sense?
Yeah.
And we are. Oh, this is what they say. Oh, they can also by theta plus pi, they can also replace by negative r, which is also another way to do that. Does that make sense? If you replace by negative r is still equivalent, then it's symmetry respect to the pole. Either this or that. Does it make sense?
Yeah.
If that's the case, there is something we had to be careful is only when that I will let's just read this and then you understand. They say This thing is enough for symmetry. This 3 requirement is enough for symmetry. But if an equation don't have this, 3 property like this, but they can still have symmetry. Does that make sense? It's a necessary requirement. But if you don't have it, you still have a chance. Does that make sense? For example, this one, they don't satisfy anything about this.
Yeah, okay, so symmetry in respect to the polar axis, the x-axis is replacing it with minus theta, and respecting the origin, that's replacing it with negative r or theta plus. Okay. Okay, yeah. Okay, yeah, that makes sense.
That makes sense.
Like,
Okay.
but why is there so many ors on?
Why so many what?
Oh wait, never mind. I get it now. Yeah.
And let's do. This is the last one we do for this, because the rest of it you can just use this ones together. There are so many of them. And also, we don't really need this at all in AP calculus. Okay, let's do example 7. That's a cardiograph. I probably should do this one. This is a little different. You can try a little first. Autograph it.
Okay, so r to the power of 2 equals
This one,
and r sine theta equals y. So r minus y.
yeah, this one doesn't really have the previous kind of simplifying XY coordinate
Oh yeah,
equation.
do we need to replace it or something?
No, we
I
can
don't know,
try.
I can't tell.
Yeah, this is difficult. So we can't really replace it as this kind of method before. Any of those we tried, and it's not working. So we return to this one we call the help for the original, way, which is the former way that we do drawing the graph by point. But this way we can't really do anything like this kind of thing before. It's not working. So what we can is do point by point graphing. Or we should use so since XY doesn't really help us, I don't really need XY. So I'm just use my polar. So if this is 1 and this is 2, if I put in, well, I better use, what should I use? I should use special angle, probably good. Maybe better. So if my theta, say my theta is pi over 6, which this is 1 over 2, right? And then my r is 1 over 2, right? Is that making sense?
Yeah.
Is that making sense? So I can just find a way. So 1 over 2 r and pi over 6, which is 30 degrees, probably here. And then the next one, which is easier for me, is pi over 3, maybe. Oh, pi over 3 is a little difficult. It's a square root of that. So next one I want to use is pi over 2. Pi over 2 is probably easier. So if it is a pi over 2, and that'd be pi over 2, that'd be 0. Well, because 1 minus 1 is 0, right? So I know r equals to 0, pi theta equals pi over 2, which is x being 0, and y being pi over 2. which is the original point, right? Is in here. Does that make sense?
Okay, so we just find that. So theta, oh, okay. So we just have to substitute in points until we find
Yeah,
it.
yeah,
I see. It looks more like an oval.
yeah, yeah. Well, not exactly. So let's just say we keep doing that until we just substitution. I don't want to do well. This one is easy. X theta equals pi over 2. Wait, this is not theta. Theta equals 0 is also equal. Theta equals 0. This is 0, and this is 1 minus 0 is 1. Oh, so 0, 1. So x equals r equals to 1, and theta equals to 0. That's this one, right? And so that's when I can draw it if they are smooth. And then what should I do? I'm having, if I go
And then
there.
I guess you just replicate on the other side, I
Yeah,
think.
yeah, let's just see the real
Oh,
graph. So then you substitute negative pi over 6, and you get
ah,
3 over 2.
okay, so you just keep substituting. So for
Yeah.
this, you just keep substituting and substituting and substituting
Yes,
for
yes.
value.
Not all of them, because we just learned symmetry, right? I can substitute what? This is obviously from the graph we can know it's there is symmetry what? From pi over 2, right?
Yeah.
Pi over 2, we learned that pi over 2 is substituting pi minus theta, right? Substitute. If I replace it, this r equals to 1 minus sine pi minus theta. Wait, sine pi minus theta is also sine theta, right?
Yeah.
So it's basically the same thing. So that's why I say it's there's symmetry respect to the theta equals to the pi over 2. So that's why we don't have to substitute all the thing, although it's already complicated. At least I don't have to substitute all this way in here, right? I just draw what's on the right, right? Does that make sense?
Yeah.
So
Okay.
symmetry does help with half the job. So this is a cardio. So this one is the one looks like a heart. And then you still don't have to memorize this. Also, it's done by point by point. What's the point of remembering this? You can. It's not bad. So and they summarize in here. If you basically get all this, this is the thing. This is also one of the reasons we want to use what we don't want to use a polar system. See, in XY system, this doesn't really have a way that we can express this. But in polar system, which is good, which is also like a shape that we like to see a lot in real life. So in all this, it's a cardinal. Of course, A have to be greater than 0 with all the testing. The rest of it we don't really have to do. Let's just take a look. With this kind, is that making sense for this question? It's basically done by like a symmetry and also point by point drawing. Is that okay? So
Yeah.
let's just say heart can be drawn by equation, polar equation. And then if we do this, it's the same thing. We test all the symmetry, and then we draw it. It eventually looks something like this. I mean, this is called a Pascal kind of shape. It's also probably done by the scientist Pascal. So this is the shape. You can just substitute this in decimals to draw it. You don't have to memorize this again. And this time it's a little bit different. Like
Oh
this.
wait, can we? Oh wait, the home. Could you repeat the homework?
Sure, sure. Let me just show you one, and all of it, the rest of it is just you can remember this shape a little bit just by polar. We can do it. We can graph it, and also by this we call it roses. Rose,
Oh yeah,
like this.
that's pretty. It doesn't remind me of a rose. It reminds me of a clover. But
Yeah. And with this, you see, the polar is a beauty now, right? R equals to 2 cos 2 theta is getting you a rose. Yes. They have a
Yeah.
beautiful story about this. And also, this one is like this. This is r squared equals to 4 sine 2 theta. None of this you have to memorize it. Let's go to the homework. We stop at the cardio, and the rest of it you can just do with the calculator. So yeah, cardio, which is a times 1 plus cos theta, a times something. Homework, let's see. Page 579.
579.
Yeah. From 20 to 23. 20 to 23.
20 to 23.
Yeah. And then 37 to 40.
37 to 40. Okay.
Yeah.
That's it?
Yeah, that's it. And well, there's a math problem, which also not that difficult. You can take a look. So let's also include 29 to 36. It's a matching problem. It won't be difficult. You just compare with what we learned in the examples. You can do 29, 36 matching problem.
Yeah.
And, yeah.
Okay, so is page 65 and page 579, 20
Yes.
to 23, 37 to 48.
Yeah. Did you include 29 to 36?
Oh, no, I didn't.
Yeah,
29 to
29 to
36.
36. 29 to 36. It's a matching problem. It won't be difficult.
Okay, yeah.
At least not that. Oh, and the next time we're gonna skipping something and get the necessary precalculus stuff for calculus. Then we finish that and we can do what's left because the most of it is not necessary for calculus. Okay, do you have other questions?
No, thank you.
Okay, good day, God bless you. Bye.
All right, bye. Thank you.